All right. To do lesson 9.4, you have to remember some things from goal 7, which was this semester. So things you will see on your final exam. So we have to remember some things from that. So that's going back to using our y equals mx plus b. So we're going to be graphing inequalities. Now we graphed equations in that form, and they graph exactly the same way. So we're going to review first for a second what that means. So once your equation is in your y equals mx plus b form, meaning that y is by itself, you have isolated or gotten the y variable by itself. The m, you'll remember, hopefully remember, the m, which is the number in front of x, whether you wrote it like this or you wrote the b first. The number with the x is my slope, and then the b is the y-intercept. And then we had that little notes where when we graph, we begin with b, and then we move to graph our m, positive slopes go up and right, negative slopes down and right. We're using all of that again, okay? So, just a little thing. So b, begin with this one. And it's the y-intercept, so it's on the y-axis. That's why it's the y-intercept. And then for our slope, we're going to move to graph our slope. And if it is a positive slope, we will be going up and right. And if it's a negative slope, we will be going down and right. The difference in the questions that we did before and the questions that we're going to do today is that there was an equal sign before. So we drew a line, and then that was the end of the answer. Here, you're going to have inequality symbols. So less than or equal to, greater than or equal to, which requires shading. Okay? Sometimes we're going to have greater than, excuse me, or equal to symbol. And sometimes we're just going to have a greater than symbol. Sometimes we're going to have a less than symbol, sometimes a less than or equal to symbol. So there is a difference. Just like on your assessment today and on goal 9.2, sometimes you did open circles and sometimes you did closed circles. So this is going to be the difference between these kind here. If I have a greater than or less than, we're going to have a dashed or dotted line. But my greater than or equal to, less than or equal to, those lines will be solid lines. So it's kind of like I said, the open and closed circles. So on linear equations, on our line graphs, we're going to either have a solid line or a dashed or dotted line. So that's how we'll distinguish the difference between the equal to part being there or not. Okay? The greater than, less than part, I'll have to show you when I get to the question. All right, so our first example is in the correct form already. Y is by itself. That's how we want it to be. So our B is a positive 2. And our M is 3 or 3 over 1. Because remember, we have to have a fraction for our slope. So we begin with B at positive 2. We'll graph our slope, which is 3 over 1. Positive slopes go up and right. This line will be a solid line because it's greater than or equal to. And then we'll determine the shading. I probably do my shading a little bit differently than other people do, but I think it's easier. It's less work. You don't have to do any algebra work to do it, okay? But you got to be watching me to do it. So once you get your line drawn, I'll wait here about 15, 20 seconds. Get that line drawn so I can show you how to do the shading part. How to get the greater than part. Okay, so if you go to your B, and you literally can do this while your pencil is on your paper, and I'll do it, I can't really illustrate it both ways, so I'm going to do it on the TV. Okay. So you go to your B, wherever you plotted B. And then you look at your symbol, and this is greater than. So if this is 2, where are the y's? The y's that are greater than 2 are the ones that are here. 3 and 4 and 5 and 6. So the y's that are greater than 2 are up here. So I'm going to shade this side of the line. So you're going to shade either one or the other side of the line you drew. So again, I go to my 2. I wouldn't even pick up my pencil. And I'm greater than, which means I'm going to shade over here.
Just the side?
Just the side. Now I'll literally do it now. So I'm at my 2. Above 2 is up here. So I'm going to shade on this side of the line. So it's on either one side or the other side of the blue line. You could, take a highlighter and shade, but that won't work when we do our other ones coming up. So I wouldn't do that. And then that's my answer. The shaded region is any point in that shaded region is going to work. Yes, dear?
Why would you shade the entire side?
Why wouldn't I?
Why would you?
Because that means every ordered pair, like this line goes on forever and ever. So it's either the numbers on this side of the line work or the numbers on that side of the line work. So in here, this case, they're going to work. All these points all the way up this way forever and ever and ever are going to work. So it's either one side of the line or the numbers on the other side of the line. So it goes on. It shades infinitely. Obviously, I'm not going to keep shading, but it's all of those points or all of these points. Okay, so the other way that you could do this, I don't do it, but I will give you the option, it is more work, is you pick a point. So let's just go on one side of the line or the other. So go -3, 0. And then you plug it into the inequality, and if it works, then you shade that side of the line. If it doesn't work, then you shade the other side of the line. But I think that's more work to actually do all that algebra that you don't need to do. Okay? Okay, let's go to the next one. Y is less than or equal to 2/3 x minus 4. So again, this is my M, this is my B. It's in the right form, so I'm ready to go. Begin with your B at -4. My slope is positive 2/3. Positive slopes go up and right. So up 2, right 3. It will be a solid line because I have less than or equal to. So if the equal to part's there, it's solid. Really bad line. And then I'm going to shade. So again, you can watch. Here's my -4. If I look at my inequality symbol, that's less than. So less than -4 would be the points below the line, which means I'm going to be shading below the line. So infinitely in that direction. Those ordered pairs in that shaded region are going to work for that inequality. So yes, you have a lot to remember from Goal 7. Okay, question on that one? Okay, let's look at this one. Yes?
I'm still confused on how you determine where to shade.
Okay, here's -4. Where? And that's my B. Look at my symbol here. What symbol does that say?
Less than.
So, where are numbers less than 4? Are they the ones here? Or are they the ones up here?
Down.
That's why you shade there. Okay? So wherever you would have to go with your finger or your pencil, if they're greater, they're up here, so I shade here. If they're less, they're here, I shade here. Okay, in my next example, y is not alone. This is going to be by far the most challenging part because some of you still are having trouble solving, which is so huge for this whole semester. I have to get y by itself, this variable. So the first thing I'm going to do is subtract the 2x. It's a positive 2x. That's why I'm subtracting the 2x. You can write this, as we did before, as either negative 2x plus 12 or 12 minus 2x. That's your choice. I like the x first. And then I'm going to divide by 6. I'm not going to erase that, which is what I did. Divide by 6. So I have y is greater than negative 2 over 6. Now if you want to leave it negative 2 over 6, it's still going to work. I personally would reduce it to negative 1/3. And then positive 12 over positive 6, that's positive 2. Now, when I go to draw my line here, it is going to be a dashed line because we don't have the little equal to part. It's just greater than. So my b is 2. My m is negative 1/3. So I begin with b at 2. My slope is negative 1/3, which is down and right. So down 1, right 3. Yes?
For negative 1/3, couldn't it also be up 1, left 3?
Yes. And I draw a dashed or dotted line to indicate that it's just a greater than or less than, not an equal to. Okay, so look at your picture. If I called this A, this part right here, if I called that A, and I call this B, where am I going to be shading? Tiffany? It's A. Because look here. So I'm at my 2. I went greater than 2, which is going to be 3, 4, 5, 6. These numbers up here. So that's why I'm shading on this side. Does that make sense? That doesn't make sense to you? Okay. Here's my 2. Here's my 2 right here. Where are the numbers on this axis? We're looking at this black line, darker black line, the y-axis. This is 2. So where are the numbers on this line that are bigger, that are greater than 2? Is this number bigger than?
Why would you do greater than?
Because that's the symbol in the question. This is a greater than. What? So this is a greater than. Okay, so look at, here's my 2. Is this number greater than 2? What is that number right there?
No, I understand
Oh.
that. It's just like your 2 isn't where your y is. So why would it be?
Because this is the y-intercept. B represents the y-intercept. This is on the y-axis. This is a y value. So we're looking for the y's that are greater than 2. So this is y is 2, y is 3, y is 4, y is 5, y is 6, y is 0, y is negative 1. So all the numbers on that axis represent y values. That's why you're looking for y's. Because this represents a y value. So when I'm at 2, I'm looking for the y's that are greater than 2. So the numbers that are bigger than 2 are 3 and 4 and 5 and 6. And since these numbers that are greater fall on this side of the line, that's why I'm shading there. I don't have you convinced. I said, I don't think I have you convinced that that's what it is.